This should be your third lecture on inverse functions. We're going to find equations for inverse functions in this lecture, and that's all we're going to do. We're going to also find out, actually, while we do that, when we know a function doesn't have an inverse. Okay, and there's a couple prerequisites. You have to know what an inverse function is. You have to know the conceptual idea of an inverse function and the notation. Also, you should be able to solve equations. In fact, you must be able to solve equations of all different kinds. Now, recall from my conceptual lecture about functions and their inverses that I said, well, if you have a function f and you plug in x to that, out pops f of x. And then if you have its inverse function, f inverse, when you plug whatever output you got from f into that, it should untie everything that's been done to x and return the original x value. Another way to think about this is you plug in x, you get out some value of y. You plug in that y, you get out the original x. What's important about this, actually, in this talk is that if we're given f of x is equal to junk with x, who cares really what it is? I'm just going to kind of give you a basic overview of it. If I give you a function, f of x equals junk with x, another way to write that is that y is equal to junk with x, because f of x is just the y values. Well, what we can do possibly is solve for x. If we do that, solving the right-hand side for x, we'll get x equals, and then on the left-hand side, we'll probably just have some junk with y. Okay, and it turns out that this is our inverse function. And it should make sense because we plug x into our regular function, we get out a y. So when we get out that y, we're going to plug that y value into the inverse function and get a corresponding x. So let's just see this in action. Suppose that we're given a function 12x minus 1. We want to find the inverse function if it's possible. First thing I'm going to say is, listen, f of x is just a function notation for the letter y, so this really implies that the y values are going to equal 12x minus 1. This means when I plug in an x value, I'll get out a y value. Well, if you solve this for x, so in other words, add 1 to both sides, divide both sides by 12, this right here should be my inverse relationship. So if f of x is equal to 12x minus 1, then f inverse of y is equal to y plus 1 over 12. Now at this point you might not be convinced, so let's go ahead and test this out. We'll test this out with x equals negative 2. So what I'm going to do is plug negative 2 in for x in the function, the original function. So we have f of negative 2, which will equal 12 times the negative 2 minus 1, or in other words, negative 24 minus 1, or negative 25. That is my y value, right? I plugged in x equals negative 2. My y value is a negative 25. Remember, the inverse takes this output and should return me back to negative 2. So the inverse function, which I'll go ahead and do in black, I'm going to plug in the negative 25 into that inverse function. Let's find out what happens there. Negative 25 plus 1 all over 12. Negative 25 plus 1 is a negative 24. Over 12 is a negative 2. So 2 got transformed into a negative 25, but this took the negative 25 and transformed it right back into negative 2. So this looks to be the inverse function, and it is. Another thing I want to kind of reiterate is that I tend to hate having f inverse of x. I always do the input for my inverse function as y. Unless you're doing an online homework program, graphing, or your instructor just is old school, which most instructors are when it comes to this stuff. I mainly like it because it makes sense, right? You plug in x to the original function, you'll get out a y. You plug that y into the inverse function, you'll get back x. Okay, so it makes sense to me. If you're using an online homework system, this is what you do at the end. You change everything that says y into x. That's all. So in other words, f inverse of x is equal to x plus 1 over 12. So all I did really is I have a function. I say, well, that means y is equal to, and then I solve for x. That was my inverse. That's all you have to do. Now I want to show you also that this is an inverse function. I'm going to prove it to you. If these two are inverses, then when I plug f of x into f inverse of x, right? And this is what trips people out here. When I plug this function, this output, into the invertible function, it should return x. This is a little bit difficult for people to see initially, so let me just show you what I'm basically saying pictorially. I did an example in the conceptual lecture where I said, well, let's evaluate a function, just this random function, at t. And so I plugged t into it, and it gave me this value out. It was a weird value, but it actually is just a function, isn't it? So I plug a letter in, I get the same function out, just with a different letter. Now I'm going to take that function and plug it into g. And when we did that, we did the math, it turned out to just return the original input, which was t. So what I'm going to do here is I'm going to say I have f inverse, and what I want to plug into it is this output value for the function f. I'm plugging in x into f, so plug x into f of x to get 12x minus 1. Now plug this into f inverse. So here's f inverse. I'm plugging in that 12x minus 1. Let's see. So here's f inverse right here. Wherever I see a variable, I'm going to put parentheses. And instead of plugging in like I did here, instead of y's, we have 12x minus 1's. So let me just write in 12x minus 1. Now I just have a fraction. 12x minus 1 plus 1 is just 12x over 12. The 12's cancel and I get x. So let's see what happened. I plugged x into my function. I took that output, plugged it into the inverse, and when I did that, the inverse popped me right back to x. Plug x in, get this 12x minus 1 out, plug 12x minus 1 into the inverse, I'll get x out. And that's the way it's supposed to happen. These are inverses, that's why it happens like that. So let's see if we can find an inverse of this function right here. First thing I'm going to say is, well, I know that f of x is just a fancy way of saying y. So that's y equals 4x cubed minus 1. I want to draw your attention to something that I've taught this entire time and through all my lectures. I've said, what happened to x? I've told you the entire time when you solve an equation, you're really asking yourself, what happened? If I'm solving this equation for x, how did they lock this x up? They made it a mess over here. Why didn't they just tell me x is 5 or something like that? The reason why they didn't tell me is because then it wouldn't be difficult, I guess. And how I'm going to figure out what they did or what the value of x is to figure out what they did to x. So I look at x itself and ask myself, what's the first thing that happened to it? Well, it got cubed. The second thing that happened to it, after it got cubed, it got multiplied by 4. The next thing that happened to it, after it became 4x cubed, they subtracted 1. So now, what I do is untie all that, right? So if you watch my lectures, you know this is what I always do. I untie the knot. This is like they're tying up x into a knot. So I'm going to undo the last thing they did. Just like when you untie a knot, you always untie the last knot. I'm going to undo this last thing. And all the way up to this point in this series of lectures, I've just been saying, well, undo what they just did. Now I'm going to start being very official. Do the inverse of what they did. What's the inverse of subtracting 1? Well, it's adding 1. The inverse of multiplying by 4 is dividing by 4. The inverse of cubing something is taking the cubed root of something. That's how I'm going to get the complete inverse function, is inverting everything. So here I go. I'm going to add 1 to both sides. And that's going to give me y plus 1. I know you guys are experts at this point, but it's just important for me to keep reiterating this. I'm going to divide both sides by 4, just following my order of operations over here. And now I'll have x cubed is equal to y plus 1 over 4. And finally, according to my order of operations right there, I need to take the cube root of both sides. So this implies that x is equal to the cubed root of y plus 1 over 4. And that 4 is underneath the cube root. So this is my inverse function, f inverse of y. And the reason why it's of y is because, well, the y is involved in all that junk. So it's f inverse. The inverse function is f inverse of y is equal to the cubed root of y plus 1 over 4. And again, if you use an online homework system or something like that, then it's going to hate you using these y's. It'll want you to write everything in terms of x's, so just switch the variable. That's fine. Just like that. So let's see if we can find the inverse of this next function. F of x is equal to 2 over x plus 3. Again, that just means that y is equal to 2 over x plus 3. Now I'm not going to do this slowly. Instead, I'm going to just mention that if you have an equation with fractions in it and you want to solve for an unknown that's not already by itself on one side, then your best bet is to first clear both sides of fractions. So I'm looking for the LCD here, the lowest common denominator. And what I see here is that the LCD, well, the denominator of y is 1. The denominator of this 2 over x plus 3 is just x plus 3. So this tells me that, 1, you must note that x cannot equal a negative 3. That's the first thing you have to note here, because it's just a good habit to get into. That your x value cannot be a negative 3. Next thing you're going to do is multiply both sides of this equation by x plus 3. So I have x plus 3 times the y value, and then x plus 3 times the right hand side. And on the right hand side, you see x plus 3 over x plus 3 turns into 1. So the right hand side is just going to be 2, and the left hand side is going to be, well, x plus 3 times y. All I've done, by the way, so far is just cleared the equation of fractions. And now I want to solve for x, but right now I have some parentheses in the way, so let me distribute. By the way, there's two ways that you could do this at this point. You can either distribute the y, or you could divide both sides by y immediately. I tend to be very long-winded when I do this, so I'm going to just clear parentheses on both sides. It's just a habit that I have. You don't have to do that. You could divide both sides by y immediately. But they get to the same answer no matter what. So we get xy plus 3y is equal to 2. And now I'm going to, remember, I'm trying to solve for x, so I'm going to subtract 3y from both sides. So I'll have xy is equal to 2 minus 3y. And finally, the only thing that's touching this x is a y, so I'm going to divide both sides by that y. So that's 2 minus 3y all over y. And this is the inverse function. So the inverse function here, f inverse of the output for the function f, is going to equal stuff with y. So 2 minus 3y over y. And yes, you can simplify this if you want. This would be 2 over y minus 3y over y, or in other words, 3. But either answer is acceptable. And again, if you're using an online homework system or you have any other professor other than me and a traditional homework, it would be f inverse of x is equal to 2 minus 3x over x. And you can test this out. You plug like 5 in for x, and you'll find out that you have, 2 over 8 or 1/4? I might as well do this. F of 5 is going to be 2 over 8 or 1/4. So let's see what f inverse of 1/4 yields. Well, that's 2 minus 3 times 1/4 over 1/4. This is called a complex fraction, so I can multiply both numerator and denominator by the LCD between the numerator and the denominator, which is 4. 4 over 4 is just 1, so I'm not really doing anything. Downstairs, 4 over 4 is 1 here, but the upstairs, I'm going to distribute that 4. When I do, 4 times 2 will give me 8, minus 3 times, 4 times 1/4 is just 1, so it's 8 minus 3, or in other words, 5. I plugged 5 into the original function, got out 1/4. I plugged 1/4 into the inverse function, got out again back to 5. So this is the inverse function. Something that I should mention is initially, right at the beginning, I had said find the LCD and mention what x cannot be. This is another reason why I hate switching variables, is because that means that all throughout this whole entire process, this x right here, all these x values, this x can't be a negative 3, this x can't be a negative 3, this x right here can't be a negative 3, nor can this x, and so on and so forth. All the x's in this chain can't be a negative 3. And in fact, when you write your inverse function, remember, f inverse of y is just another way of saying x. So in other words, we're saying that whatever the function inverse is equal to cannot be 3. Okay, so far I'm just saying, or negative 3, I'm sorry. So far I'm just saying that this x right here can't be a negative 3. The issue is once you swap variables, you have no clue. Right now, it just makes no sense. Well, I suppose it does, because if I swap variables, then what would take the place of x not equaling negative 3, we would then say, well, y can't equal a negative 3. Right? Y can't equal negative 3, but often when we're talking the domain of a function, well, we're not talking y's, we're talking x's. So it's this whole swapping values is kind of weird. I would like to know what x can't be. Well, in this, x can't be 0, actually. So it's just a weird thing. By the way, had you tried x equals a negative 3, you would get division by 0 with the original function. If you tried y equals 0, you would have gotten division by 0, but you would have had this negative 3 hanging out there. They're kind of related to one another. I suppose that entire conversation is pretty worthless now that I'm thinking about it. So let's try another example. Here's an example of the 7th root of x minus 10 is equal to a function, or in other words, that y is equal to the 7th root of x minus 10. If you list out what's happening to x, you lost 10, then they took the 7th root. So if you think about how you're going to build up the inverse, you're going to undo each of these. Untie this knot starting with the last thing they did. They took the 7th root, I'll take the 7th power. That's the inverse of the 7th root. They subtracted 10, I'm going to add 10. That's the inverse of subtraction. So here we go. Take the 7th power of both sides, so that gives me y to the 7th is equal to, and then 7th power of the 7th root unlocks, so that's x minus 10. And then I'm going to add 10 to both sides. So y to the 7th plus 10 is equal to x. I can easily see that this is actually a function because if you plug in different values for y, like y equals a negative 3, it only returns one value for x. If you plug in y equals a negative 10, negative 10 to the 7th plus 10, that's just one value. So this is a function, and this is our inverse function, in fact. So the inverse function in terms of y is equal to y to the 7th plus 10. Swap those variables. In other words, turn these into x's if you have to, basically. It's unfortunate. All right, so let's go ahead and try another example. Okay, so in this case, we have a logarithm as our function, plus 9. So again, I just start this whole process with y equals. Hopefully I could solve this for x. And if you're following my lecture series, I really haven't told you that, officially, I haven't written it down that exponential functions and logarithmic functions are inverses of each other. So I'm not going to use that here. But I am going to use a little, a little theorem that we've introduced already in the past. And that would be the definition of a logarithm. The log base b of x equals y is the same thing as saying b raised to the y power is equal to x. And I call that the circular argument. If you write it this way, log base b of x is equal to y, then you can write b raised to that y power is equal to the inside. That's a logarithm is the same thing as an exponent, so you write as exponential form. Unfortunately, in our situation, I don't just have a log base b of x by itself on this side. I have a plus 9 as well. So let me get that 9 over to the other side by subtracting 9 from both sides. Because that definition did not say log base b of x and then plus 9. It didn't say that. It just said log base b of x. And in here, you know that if you're missing the base, that implies it's base 10. Okay? So that is a base 10 logarithm. Now, doing the circular argument, we could say that this tells us 10 raised to this power, so that's raised to, is equal to the inside. So let me write that down. 10 raised to the y minus 9th power must be equal to the inside, which is x minus 3. That's me undoing the logarithm, or basically rewriting it in exponential form. Now remember, this entire time you're trying to solve for x, and now all I have to do is add 3 to both sides to solve for x, and that will imply, by the way, that was implied that there, that 10 to the y minus 9 plus 3 is equal to x. Therefore, f inverse of y is equal to 10 to the y minus 9 plus 3. And again, if you have a traditional textbook, traditional teacher, traditional or online homework, it would be f inverse of x is equal to 10 to the x minus 9 plus 3. On exams, for me, I tend to accept this. I accept both, but I'm okay with this one right here because it makes sense to me. But again, online homework, you can't do that. So let's go ahead and try this one. Y is equal to 7 times 10, and I didn't have to write that 10 with a 3x on the inside. I don't know why I did that. It's 10 raised to the 3x power. And first thing I'm going to do is I want to get x by itself. You could list out what happened to it. I could have done that in the last example, but because we haven't talked about inverses yet, it's very difficult for me to say it. So first thing that happens to x here, though, is it gets multiplied by 3. Second thing that happens to it is it gets raised into an exponent, base 10. So base 10 exponent. And then once it's 10 to the 3x, it gets multiplied by 7. So let's go ahead and undo or take the inverse of all these steps. Divide by 7. Remember, inverse and reverse order. I'm going to change from an exponential notation to a logarithmic notation, base 10. And finally, I'm going to divide both sides by 3. And by the way, if you haven't had logarithms in your course yet, don't worry about it. You get a good preview here. That's all. Let's go ahead and do this. First thing we're going to do is divide both sides by 7. So that means that this is just going to be y over 7 is equal to 10 to the 3x. And then I say I have to change it to a log. Well, remember, when you're switching between logs and exponentials, this is essentially, well, it's essentially saying that log with the same base, there's a base 10 on this exponential, so it has to be the same base, of y over 7 is equal to the exponent. Now, just double check your work. I always find this very important to double check. 10 raised to that power is equal to y minus 7. Is that what we had? 10 raised to the 3x is equal to y minus 7? Or y over 7? I keep saying minus, but it's supposed to be over. Is that what we had? Absolutely. That is exactly what we have here. So this is changed into logarithmic form. All I need to do is divide both sides by 3 now to get x by itself. So let's go ahead and do that. That implies, and by the way, this is also supposed to be implied, when we divide by 3, we get log base 10, which I don't have to write the base in if it's base 10, all over 3 is equal to x. So that means the inverse function is going to be log of y over 7 divided by 3. Not bad. And you can check that this is a function just by plugging in values for y that you want to plug in. Just remember one thing. Inside a logarithm, you can only have positive values. So y has to be positive here. It's just going to be forced to be positive because the fact is you can't take a logarithm of a negative number. But you can already see right here, this has to be positive as well, right? Because no matter what x is, even if x is negative here, y will always be positive. Try it out. Grab a calculator, just plug in any value you want for negative, for x. Allow it to be negative. I promise you, y will never be negative. Okay? All right. Something that seems like we're stepping backwards, a little simpler as far as examples go, is not simple actually. I'll start like we always have. I'll start solving. You can list out what happened to x. First thing that happened to is it gets squared, right? Next thing that happens to it, it gets divided by, or not divided by, it gets multiplied by 2. And then the next thing that happens to it gets added to by 1. So to find the inverse function, we're going to subtract 1. We're going to divide by 2. And then we're going to take the square root. And this is where we have issues. Okay? I'll show you in a moment why. Subtracting 1 from both sides, we get y minus 1 is equal to 2x squared. And dividing by 2, you get y minus 1 over 2 is equal to x squared. And now take the square root of both sides. Remember, when x squared is equal to a number, and you take the square root of both sides, the square root of a square is not, those two don't actually undo each other. So recall, if x squared is equal to k, then when you take the square root of both sides, you'll get x is equal to plus or minus the square root of k. The reason why is that x could have started as a negative number. When you square it, it could become that positive k. So it could have been negative or positive to begin with. We have no idea. So when I take the square root of both sides here, this will imply that x is equal to plus or minus the square root of y minus 1 over 2. Now ask yourself, is that a function? When I choose a value of y, like let's say 1, when y is equal to 1, well, that works out, right? Because then x will equal to plus or minus 0, which is just 0. Okay. But when y is equal to, let's go for 3, then x is equal to, 3 minus 1 is 2. 2 over 2 is 1. So it would be the square root of 1, which is 1. X would be plus or minus 1. So plugging in 3 to my function, or to what I'm hoping is a function, and I get out two possibilities. This is not a function. Because of this right here, because of plus or minus, we know it's not a function. FNC is my shorthand for function. That does happen, especially with even powers. It happens quite often. In fact, it always happens with even powers, as long as that's the degree of the polynomial. So, in this case, we would say that f is not invertible. F is not invertible. And then you get into a case like this. This, you might as well just throw the pen down. When you have multiple powers of x with your function, it could be invertible, but likely it's not. In fact, it's likely not. And if it were, it'd be nearly impossible to find. The reason why, remember what our ultimate goal is: to find the inverse function. We want to solve for x, right? But how am I going to get x equals just y? Because that's what I want. I want dot, 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 dot. I want to do all a bunch of work and get x equals stuff with y. But y only. And unfortunately, I can't get x by itself because there's 3 different versions of it here. There's no way to get x by itself. It's just not going to happen. So this one, it doesn't necessarily mean that it's not invertible. It just means that it would be very difficult to find the inverse. So I'm going to say too difficult to find. By the way, don't let anybody tell you that because it's in this form, it's not invertible. It could be. The one thing that I can tell you right now, this is not invertible, is because of the even power I see right here. Once I see an even power, I just happen, because I've dealt with math long enough, I know that it's not going to be invertible, because I'll have, anyway, it doesn't really matter, I'm not going to say it. But if it was just, let's pretend we took that middle, or that second term out, and it was just 3x cubed plus x minus 1, that right there, that is invertible, but I still can't find the inverse. I'm not going to even bother. So, to summarize everything we've done, to find the inverse of f of x, you let y equal f of x, because that's what it is, solve for x. That's it. This is f inverse of y. I know, I make a very long video for just that, right? Swap variables to get f inverse of x. And again, that last step is only there because, well, because authors force you to do that. And what I might do is I might start the next video with a good example as to why I super hate that. I mean, I've tried to give good examples on that anyway, but try to give another one.